Hello. Today we're going to look at section 5.3 extension, and it is called Relating Arithmetic Sequences to Linear Functions. The first thing I would like for you to do is to pause this video and see if you can figure out the next numbers for questions 1 and 2. Okay, hopefully you found that number 1 was a pattern of adding 7. If you add 7 to negative 12, you will get negative 5. Add 7 again, you'll get 2. Add 7, 6, or you'll get 9, then you'll get 16. And the pattern was add 7. Looking at number 2, you will notice that the pattern is to multiply by negative 2. And when you multiply by negative 2, you have an alternating sign that's occurring. So times negative 2, you get negative 6. Times a negative 6 by negative 2, you get a positive 12. So your pattern will end up being 48 positive, then a negative 96. So both of these examples are sequences. So what exactly is a sequence? A sequence is an ordered list of numbers. So you can see in the previous examples, they are both ordered, and it's a list of numbers. Well, this year we will actually look at two types of sequences. One is called arithmetic. If you notice, that is the title of our notes. The other one is called geometric. Now, if you look closely at the examples, you will notice example 1 is arithmetic because it adds. Example 2 is actually geometric because it multiplies. We will not be studying this until later in Chapter 8. So what our focus will be today is on the arithmetic sequence. So let's go down to the next box. And it says in an arithmetic sequence, the difference between consecutive terms is constant, as if it does not change, it stays the same. This constant difference is called the common difference. So let's look at another example here. We have negative 6, negative 13, negative 20, negative 27, negative 34, ... So if you look at this and try to make it make sense with this definition, how do we know that it's arithmetic? Well, there is a constant difference between each ordered list of these numbers. So it says consecutive terms. Each number in the list, that's where your terms come in. And then there's something called this common difference. Your common difference is really like slope. It is the pattern that is adding or subtracting. So that is the key with arithmetic, is that it adds and subtracts linear. So the common difference we normally refer to as D, and here the common difference is when we add a negative 7. And you can see that's how the sequence will go. So the next part here, it says tell whether the sequence is arithmetic. Remember, it must add or subtract. It cannot multiply. It cannot do any other thing such as adding the odds or adding even numbers. If it is an arithmetic sequence, tell what the common difference is and then find the next two terms. Pause the video and attempt 1 through 5. Okay, let's look at number 1. I have yes. Common difference is adding 5, and the next two numbers will be 21 and 26. That one is very straightforward, and it is an easy pattern to find. The key is the common difference of adding 5. However, on number 2, I notice the pattern goes add 2, add 4, and so on. So it does not have a common difference, therefore it is not an arithmetic sequence. So it does not have a common difference. You can, however, find the next two terms if you choose to. Question 3 is also yes, because you can see that each term is subtracting 3. So the common difference would be to subtract 3. The next two terms would be 23 and 20. Question 4 is also yes. You can see here the numbers are decreasing by 30 every time. So the common difference is negative 30, and the next two terms will be negative 154 and negative 184. Question 5 is not arithmetic because 1, 4, 16, 64, 256 does not have a common difference. However, you can fill out the pattern as 124 and 4096. So today we will not really talk about 2 or 5 because it's not arithmetic. We will only talk about the ones with common differences because those are linear. Okay, if you'll turn your paper over, we are now going to talk about graphing a sequence. And not just any sequence, we're actually going to only be graphing arithmetic sequences. So we have 3 steps. The first step, we have to number the terms in the arithmetic sequence. It's almost like place value holders. Step 2, we are going to create a table, and we are going to let X be the term number, as in what place are they in, and Y, that's going to be the term. Step 3, we will then plot them. Now let's make sense of this in problem number 1. If you notice, I'm just giving the arithmetic sequence. I don't see a table, I don't see much how I can graph it. So this is how we approach this type of problem. Okay, so you've got your sequence. The first thing, it is arithmetic. It is adding 5 every time. So we are going to number, like it says up here, the terms in the sequence. So 4 is in the first place, then second, third, fourth, and fifth place. So then you create a table and you say in the first position is the negative 4. Second position will be 1, and so on. So you just simply tell what place they are in. Well, now that we have a table, what we're going to do is simply graph it on our coordinate plane. So let's put our x-axis here, and let's draw a y-axis here, and now simply plot the points. So 1, negative 4, 2, 1, 3, 6, 4, 11. And you can tell I'm already running off the graph. So it's going to be up here, and I'm going to stop. Now, it's discrete because they gave them to us as a sequence. So at the moment, we're just going to leave them as dots. Okay, let's go over to number 2. Okay, here is the sequence. 0, 2, 4, 6, 8, dot, dot, dot. First thing, is this an arithmetic sequence? Yes, because the pattern is add 2 every time. So, remember, we are going to make a table, and we have positions. We have 5 positions. In the first position, we have 0. Second position is a 2, then a 4, then a 6, then an 8. Okay, pause the video and graph it. Okay, you can see my answer here. Okay, now I would like for you to try number 3 by yourself. Here is your sequence. Negative 3, negative 4, negative 5, negative 6, negative 7. Please pause the video and try this one yourself. Okay, here is the answer for number 3. Notice that I had to move the x-axis up because the sequence were negative. The common difference there was negative 1. Now, what's very important about these three graphs is for you to notice something. So it says, what do you notice about the points we plotted in the above graphs? Well, you notice that they are linear. And that is the key with our lesson today, that arithmetic sequences are always linear because they have a common difference of adding or subtracting. Now, the next part is how you take your graph, you take your sequence, and you actually write the rule. And remember, we've been writing the rules, and we say write the equation. So this is weird notation that you may not be used to, but it's very easy once you get used to this notation. So it says to find the nth term of a sequence. The nth term is just one that you don't know. You can write the rule in the form of a sub n equals a sub 1 plus parentheses n minus 1 times your common difference. Now, a sub 1 tells you it's the first position. So it says where a sub 1 equals the first term and d is your common difference. Now, to help with the notation, just remember that a sub 1 is the first one in your t-table. It's the first point. And your common difference is really your slope. So we have graphed this guy right here in this graph, okay? So I'm going to show you how to use this formula. It's very similar to point slope form. You just have to notice where to get the numbers from. So for number 1, we have the sequence. It says to write the rule and then give the final given term. So here, I notice that it's the same thing, and we've already figured out that the pattern is add 5. Now remember, this is a sub 1 because it's the first one. So if I plug into my formula a sub n, I say a sub n equals a sub 1. It's the first one right here. So negative 4. Plus n, I don't know n, minus 1 times the d. Well, the d is the add 5, so we put a 5 here. That's all I had to do. So negative 4 was a sub 1, and the common difference, or our slope, was add 5. So that's our rule. That's it. But then it says to find A17. Now, all you do is you ask yourself, it's the 17th number or term in our pattern. Well, it would take forever if we actually would write that out or do it on the calculator. So the rule will help us very quickly. So this is how we do this one. We say A sub 17 equals. You take your rule, negative 4 plus parentheses 17 minus 1 times 5. So when you clean that up, A sub 17 equals 76, because 16 times 5 is 80, added to negative 4 gives you 76. Now, I would like for you to pause the video and attempt 2 and 3. Here are your problems. 4, negative 3, negative 10, negative 17. The next one, negative 3, negative 4, negative 5, negative 6, negative 7. Pause the video and try both of those. Okay, here is the answers for questions 2 and 3. If you have any questions of where these came from, please make sure you ask me in class.